My name's Gene Kindred, and I work here in the Wings of History Museum prop shop. This prop shop has quite a bit of history, just a little bit. It was everything in here, such as the press and other tooling and the balance station and all that, is from Ole Fahlin, who originally started this. But it's a long story, and I won't go through all that. But he moved from Missouri to here in California, and moved a couple of times in California, and ultimately wound up here at the museum. The museum offered him the space, so any props made in here are actually a revenue generator for the museum. Talking about Ole Fahlin and how long he was in the business, we have here what we call shaper boards that define the shape or the plan view of the propeller itself, and they're all from post World War I up to World War II, possibly even into World War II. So as you can see here, we have many of them here for different airframes, engine combinations. So just about anything you would want to restore or build a replica of, we can probably accommodate it. And if we don't have the particular shapes that we need, if there's an older prop around someplace that we can copy, then we can get the shape out of that. But even with all these, we still don't have enough room to hang them all. So we've got these barrels with more shapes in here. The wood we use here to make the propellers is all hardwoods, and we can use, we've used in my time here about 3 different types of woods. The most common one that we use is birch, and this is a supply of birch for the next prop order that we get. One of the other types of wood is mahogany, which is a darker reddish wood. And the mahogany that we get is from Africa. Used to be able to get mahogany out of the Central Americas, South America, but that's all pretty much environmentally controlled now, so that those countries can't ship wood out to us. This wood, the process is to clean these boards, both sides, and mix a glue, weldwood glue. It's a 2-part, powder, water, and we smear it on there, stack the boards, and then once we get them as thick as we need them for the particular application, we have to put them in a press. And this is an Ole Fahlin design press, pretty basic, but we put the propeller down on the lower level, and then we lower a big heavy log on top, and depending on how thick the prop is, we have other wood over here that we stack on top, and then using, I don't know if you can see it there or not, but these are house jacks down here that we squeeze between here and here, and squish that thing down till we squeeze almost all the glue out. It'll come out, and then we know when we've got glue leaking out all around that we've got all any bubbles or anything like that no longer existing in the glue between the layers or between the laminations. We don't have an environmentally controlled shop here, so depending on the type of year, we let that cure for 4 days to maybe up as much as 2 weeks. In the winter, 2 weeks is common. In the summer, 4 days is common, and that gives it a good solid glue seal. We've even taken a section of a piece that we've done that way and tried to break it at the glue line, but the wood breaks first. So it's a really strong glue joint. This is a sample of the wood that was used, that layered up for another prop at some point in time. And we used a piece like this to test the strength of the glue. You can see here, you can see the different colors of the layers, but you can't see any glue there. This is the edge where the glue actually got squeezed out. And we took this, a piece like this, probably a little wider, and put it on an angle and hit it with a hammer as hard as we could until we got it to break. The glue never broke. The wood broke before the glue ever separated. So that's just an indication of how strong this is. And when you laminate wood, people sometimes ask us, do we use a solid piece of wood? And the answer is no. And when you layer or laminate it like this, the strength is much greater than just a single piece of wood. Okay, so this is one that we are currently working on. This is a shape for a prop that we're currently working on. This is for a Stinson L5 with a Lycoming 0435 engine in it. And I think all the L5s probably had the same engine. But this is the shape that we copied off an original Lycoming L5 propeller that we were allowed to borrow to get the shape off of it. As I mentioned, the propeller is the shape of a wing. And in order to get the right shape at the right place, some people don't know anything. They come through the museum and we explain to them how we make propellers. They think we somehow twisted this wood because you can see it's almost level here, and back here it's obviously not. And it looks like it's been twisted, but it's not been twisted. It's actually been sanded and carved into that shape. So at each 6-inch point, this is out from the center of the hub, it has a different shape and a different angle. Now the shape is defined like this is a 36-inch camber side, which is this side, the side that is in the front of the airplane, is pulling it through the air. And this is the 36-inch template, and the 36-inch scribe line is right there. This fits on there, and every 6 inches we have a different one. So this is the 30-inch one, and so this one would go on here. And I don't know how well you can see that, but you know, it just walks down. And so we have to carve these. We start at the tip and shape it, and you know, just work our way up to the hub. The critical part from a performance standpoint is about from here out to the end. In here, it's just basically aesthetics, where you just make it look nice. Because this doesn't actually, in here, the blade's not rotating fast enough to develop any thrust. So all the thrust, all the working part of the blade is, you know, basically three quarters of the blade. The rest of it is just making it look right and having it fit. So when the log, what we call the rectangular piece of wood that we've laminated together, we call that a log. And when it comes out of the press that we just showed you, we then put it on the bandsaw and cut the basic shape. So you're seeing that this is all very, very manual, and it's all rough up to this point. The next step would be to cut the center hole and the bolt holes in here, and we do that by moving that cut wood over here to the mill, the Bridgeport mill. And we have tools that we're able to use to cut the center hole, and then we have many different sizes drill bits that we can put in here, and you know, just crank it down and drill through it. This table also, if you're familiar with these old manual presses, not press, but mills, this table moves back and forth, and it moves this way. It's three-dimensional, and it also moves up and down. So with those motions, we can continue the process of you know, the next step in defining the actual what's going to be a prop. As you can see, up to this point, it doesn't look much like a prop. I mean, you can maybe start to imagine that this is a prop, but it's still extremely rough. To get it to look more like a prop, then we have to put it on this table here, where there are scribe lines at every 6 inches. There's one here at the center, and then every 6 inches out, there's a scribe line, and we cut the angle of the blade. We have specifications from different publications to say what that angle is. And then it also, a propeller is just a rotating wing. So the shape of the prop is the shape of an airplane wing. So it's got a camber side, which would be like the top of the wing, and on the back side is basically flat. So then, and this is all by hand. We use grinders and sanders, belt sanders, rotating sanders, and grinders to define, well, the templates that we use define the shape, but then we have to put these templates on and put them on, sand off what is not propeller, and so that when we get done with it, we actually have a finished propeller, finished in terms of shape. Now, there's a lot more work that has to be done on them to actually turn it into a working propeller. So what you see is a finished propeller. There's a lot more detail work that has to be done on it. Things like putting a brass tipping on the leading edge. That brass tipping is there, usually goes from the end or the tip of the blade into about this part, and it protects the wood from foreign object damage, or what some people call FOD. You don't want things like rocks that are picked up off the ground to erode the leading edge of the blade, and even if you fly a plane, probably don't fly a real antique airplane in the rain, but if you did, or you got caught off airport and had to fly through rain, that brass tipping will also protect the blade from that. So then it's just a matter of fine tuning, sanding, making the wood the right shape, making it nice and smooth, getting it to balance. We do a balance on this station right here, and we balance it both vertically and horizontally, so that it horizontally it balances this way, and vertically it doesn't rotate when it just stands there vertical. And that is pretty much it, other than putting final varnish and tip coloring on the prop. And this process takes, with somebody who's pretty good at it, 2 to 3 months to actually go from coming in as raw wood to going out as a finished propeller.